In this lesson, we'll talk about how to use theoretical and experimental probability to make predictions. And so in example 1, it tells us a coin is tossed 50 times and it lands on heads 28 times. This is not a multiple question problem. This is not a multiple choice question. This is multi-part. And so the first part asks me to find the theoretical probability. So this is what should happen. When I have a coin, there are two possible outcomes, heads or tails. And so my favorable outcome is 1. So 1/2 or 50%. That's the theoretical probability. However, for experimental probability, I'm going to use the data. So there were 28 out of 50 trials. So 28 times it lands on heads out of the total 50 trials. If I reduce my fraction, that reduces to 14 over 25. You can make it a percentage, but you don't have to. Now for question C, it says, if you toss the coin 150 times, based on the theoretical probability, how many times should it land on heads? And my note tells me to use a theoretical probability and create a proportion to make my prediction. So when I go back to theoretical probability, I got 1/2, so 1 out of 2 times. And I'm saying if I flip it a total of 150 times, that's the number of times I'm going to flip it. So that's my denominator. And I'm looking for the number of times it should land on heads. So x over 150. Proportions, I told you to make sure you included the unit. So let's do that. It would be 150 flips. And this is the number of times it lands on heads. So heads in the numerator, and then the total number of flips or outcomes is my denominator. When I cross multiply and then divide, 150 equals 2x. Divide by 2, that gives me 75. That means that it should land on heads 75 times, which is half of 50, which makes sense. Now let's try part D. This time it says if I toss the coin 150 times, based on the experimental probability, how many times should it land on heads? So we calculated in part B that the experimental probability was 14 out of 25. So I'm going to use that. 14 out of 25 equals x over 150. Again, I'm looking for the number of times it's going to land on heads. So I keep the heads, or the favorable outcomes, in the numerator. That helps me to set up my proportion. Now I just need to cross multiply and solve for x. 14 times 150, 2,100, and then 25x. Now I just need to divide by 25. And when I do, I get 84. That means based on the experimental probability, it should land on heads 84 times. Now, my theoretical and my experimental probability, I did not get the same results. They're pretty close, and if I were to do the experiment even more times, then it should even out to be about half of the time. Now I want you to pause the video, try example 2 on your own, and then play it to check your work. The spinner at the right is spun 12 times and lands on blue 1 time. First, I have to find the theoretical probability. So that's just what should happen. I'm going to look at my spinner. I'm not even paying attention to my data. So on my spinner, I have a total of 4 sections or 4 possible outcomes, and only 1 section is blue. So that's why my theoretical probability is 1 out of 4. Now for my experimental probability, that's where I got to look at the data. I spun it a total of 12 times. My total is in the denominator, and it only landed on blue 1. So my experimental probability is 1 out of 12. Now I'm going to use my probabilities to make a prediction. If I spin a spinner 50 times based on the theoretical probability. So my theoretical probability, I got 1 out of 4. So every 1 out of 4 times, it should land on blue. Now I want to know if I spin it a total of 50 times. So 50 is my denominator, that's my total. And my numerator, I have the number of times it lands on blue. And I don't know, so that's going to be x. Now I just need to solve. 1 times 50, 50. 4 times x, 4x. Now I'm just left with a one-step equation. Once I divide by 4, I get x equals 12.5. A decimal doesn't make sense when I answer this question, so let's round to the nearest whole number. We can expect that based on the theoretical probability, it should land on blue 13 times. Now for part D, this time it's based on the experimental probability. And so my experimental probability was 1 out of 12 times. 1 being the number of times it lands on blue, 12 being the number of times that it was spun. And so it says if I spin it 50 times, 50 represents my number of spins, and I'm looking for x, the number of times it's going to land on blue. Now I just need to solve my proportion. 1 times 50 is 50. 12 times x, 12x. Once I divide by 12, I get a small decimal of 4.16, which rounds to approximately 4 times. Based on the experimental probability, it should land on blue 4 times. Now, I want you to pause the video, try example 3, and then play it to check your work. In example 3, I want to make sure you take your time and read the problem. It says, when playing a board game, Marisol rolled a number cube 10 times. She rolled an even number 7 times. Based on her results, what is the experimental probability Marisol will roll an odd number on her next roll? So I don't even need to calculate the theoretical probability because this question is only talking about experimental probability. And so it tells me that she rolls even 7 out of 10 times. So that would be my experimental probability for even. However, the question asked me how many times she's going to land on odd. And because odd is the opposite or the complement of even, I'm just going to say 10 minus 7 is 3. So it should be 3 out of 10 times she lands on odd. And then my correct answer choice is B. All right, so in this lesson, we learned how to use the theoretical and the experimental probability to make predictions.